we're going to talk about concentration. Okay, we skipped over a bunch of stuff in the middle of these notes. The notes are there for you to refer to. Factors that affect solubility and dissolving. We know this. We know if you want to dissolve sugar, it's usually dissolve sugar in hot water than this cold water, don't we? We know if you stir it, that's what agitation is. It dissolves better. Okay. We know that oil and water don't mix. Okay, those are immiscible things. Okay. Big rule in there is like dissolves like. Chem 2 people will talk about that a lot more next year. Talking about your intermolecular forces and things like that. But the part we just skipped, those notes are when we have a test over it, that will be on the test. But I mean, I think most of those things are pretty common sense things that are in everyday life. Today we're going to talk about concentration. We're going to begin to talk about concentration. Concentration is a measure of the amount of solute present in a solution. Okay, it's a measure of a solute amount. Okay, concentrated solutions have a lot of solute present. Okay, that's why you can go buy concentrated orange juice mix, can't you? And it's typically that one little frozen can, and you mix it with water to dilute it out. Okay, to dilute it out. Yes. So there are a lot of units of concentration. I have 4 on here. We're going to talk about, there are some other ones. We're going to typically talk mostly about the top 3 though, okay? Molarity, molality, mole fraction, parts per million, and there's a lot of others like normality and some other things like that, but it's not as important, okay? Today we're going to talk about molarity. Talk about parts per million. I talked about this yesterday. I think we talked about like your water ranges had to be like certain things. That's how they measure. You can have bacteria in the water. I don't know what our acceptable parts per million range is. Okay, but your water is tested every day at water treatment facilities. And if you get over a certain number of parts per million, then that's where you get a boil water alert. Okay. If there's too much bacteria or something else in there, you get a boil water alert. You boil the water and it should kill the bacteria. So we won't really calculate parts per million in here, but that is something that's probably one of our most commonly used ones. Molarity. Okay, molarity is the first one we're talking about, and that's going to be today's focus. Okay, molarity is defined as the number of moles in 1 liter of a solution. You haven't paid much attention to this, okay? But like when we did our lab on the other day, you used a 0.25 molar solution, didn't you? Okay, that's wasn't very concentrated, it's very dilute. You have some things like on here, I have a 6 molar, and sometimes it says molar, sometimes it says big M, concentration of sodium hydroxide. That's the Chem 2 kids are using. It's 0.2 molar of zinc nitrate, okay? So in 1 liter, there's 0.2 moles of zinc nitrate dissolved in there. So we use that concentration a lot, okay? Use the concentration. I would say molarity is probably the most commonly used concentration, okay? Now, can everything have the same concentration? Can I have a 200 molar solution of something? Probably not, because we know that this goes to your saturated, supersaturated, unsaturated. We know that there's a certain amount of stuff that can be dissolved, don't we? Remember, the solute is the thing that's present in the least amount, okay? So there is a range of where you can have where it can dissolve more. You can't put 8 cups of sugar in a gallon of water and dissolve it, can you? It won't dissolve, okay? So you can find the concentration of the sugar, that's your solubility, saturated, supersaturated, unsaturated. For example, concentrated HCl is a 12 molar solution. Concentrated HCl is a 12 molar solution. Get some tweezers. Concentrated sulfuric acid is an 18 molar solution, okay? So you can dissolve more sulfuric acid in water than you can HCl, okay? We won't talk about why, but that's just something that you need to know. So it's the moles per liter. Its symbol is a big M. Its symbol is a big M, okay? So capital M is molarity. Molarity, here's the big thing about molarity, and this is why it's not always used. Molarity is based on volume, so it is temperature dependent. Because as you cool water, what happens to it? As you cool water, what happens to its volume? What? Did it go down? You ever put a soda in a freezer? It's going to freeze and bust. It's going to increase. The volume's going to get bigger. You know, ice trays, you go fill up your ice tray all the way? You make an ice tray? Or do you only fill it up about 2/3 way full? And then when it freezes, and then when it freezes, it gets bigger, okay? So that is a problem with molarity. That's a big thing. A question in your test would be, why would you use molarity? Or why would you not use molarity? Or what's the drawback of molarity? Is that it is temperature dependent. Tomorrow we're going to talk about molality. Well, I mean, Monday we're going to talk about molality, and it is not temperature dependent, okay? Molality. So our equation, molarity is a big equation. Molarity is the number of moles per liter. Molarity is moles per liter. I can write that another way, okay? I can say molarity is moles per liter, or a mole is defined as the grams divided the mass divided by the molar mass, okay? So those are the same two equations, okay? Those are the same two equations because a gram divided by the molar mass, if you have 7 grams inside, you take what you know, you put it over 1, you multiply by 1 mole over the molar mass, so you're really dividing mass divided by molar mass. So these are the same two equations, depending on what you're looking for. If it gives you grams, I'd probably just use this equation first instead of doing a stoichiometry problem first, but you could do a stoichiometry problem to do it. These say the same thing, okay? These say the same thing. Given moles, you're looking for this one, you use this one. Given grams or looking for grams, you use that one, okay? Use that one. So molarity examples, and let me pause. All right, so which version of the equation am I using? Molarity is moles divided by liters, or molarity is grams divided by molar mass divided by liters? The first one, because I'm given moles. The first one, because I'm given moles. So I'm going to say that molarity equals moles divided by liters. So my big M is my question mark. That's what I'm looking for. My moles is what? Moles is 3.25. What did you say, Nikilian? This letter right here where my mouse is? That's a big M. And then my liters are what? 6.50. So to do this, big M would equal 3.25 over 6.50. So what's the answer? Wrong. 0.500. Significant figures matter. So 0.5. I need 3 significant figures. And what are my units of this? Big M. Either moles per liter or big M. I will almost exclusively write it as a big M, okay? Or moles per liter would work, okay? Big M. Next example. Yes, a little bit. Well, not necessarily. Our next example. How many moles of sodium sulfate must be added to make 125 milliliters of a 0.43 molar? And that's how you read that. That's read as a molar solution. So as you're writing this, I'll go and ask the question: moles per liter or grams per molar mass per liter? Which one are you using? Which one? The moles per liter. Why? It's not asking for grams, it's asking explicitly for moles, okay? It's asking explicitly for moles. So what is my big M in this problem? I'll let y'all hold it. So I have big M, moles, and liters. All right, so what is my big M? What is my concentration? What's my molarity in this problem? Say that 0.43. How many moles do I have? That's my question mark. That's what I'm looking for. What are my What about my volume? It is not 125. Okay, you're correct. You have to get it to liters, so you have to divide that by 1,000. So you would do 125 divided by 1,000, and it would be equal to 0.125. So now I have 0.43 equals X over 0.125. It's a math problem. So how would I solve this one out then? Multiply both sides by 1.25. So my answer would be 0.43 times 0.125. What does that equal? 0.054 moles. And is that the correct number of significant figures? Yes. The zero in front of that is not significant. Okay. The zero in front of it is not significant. Zeros in front of a number are not significant. You're going to get a little bit harder now. Pardon me, Amelia? The grams or the moles equation. Second equation. So I have big M equals, grams equals, molar mass equals, and liters equals. So what is my molarity? So that's my question mark. What's my grams? 45.6. Well, what about my molar mass? No. Yes, I'm sorry. Yes, I'm sorry. My bad. My bad. Yes, molar mass of HCl. I'm sorry. My bad, Aaron. 36.461. Because I'm sorry, Aaron. I was thinking of. I thought I had sulfuric acid on there. So remember when I'm doing molar mass, I care about the decimals. Chlorine had 3 decimals. Hydrogen had 5, so I need 3 decimals in my answer. And now what about my volume? What about my liters? 1.00. Because keep in mind, water is the solvent. Okay? So when you find the molar mass, you can find the molar mass of the thing being dissolved. HCl is being dissolved. So this would work out as big M equals 45.6, 36.461 divided by 1.00. So you put in the calculator just like that. And you're going to get like 1.2 something. What? 1.25? And my units of that are big M. Any questions about that example? All right, another example. Oh. All right, so am I using my first equation or my second equation? Second equation. So that is molarity equals grams equal molar mass equals and liters equal. What's my molarity? 6.00. I don't know the grams. That's my question mark. Molar mass? 7 digits, 1.5, isn't it? And what about my liters? 0.125. So now this sets up a 6.00 equals X over 39.9972 over 0.125. Not quite boiling. 34.99. 39. 39, yeah. I tried to fix it. So how would I solve this one out? This is where this really gets out. This is the only spot where this really gets difficult. Nope. Multiply everything. You multiply everything. Do 6.00 times 0.125 times 39.9972. As long as you times them all together. It doesn't matter which order you multiply them in. So what's the answer? 30.0, and that's grams in AOH.
Do we have to have the NaOH?
No. I'm gonna do at least one more example. Any more questions about that? Any questions about that problem? We're gonna get a little more. The solving the math is where this gets difficult. Okay. All right. Next example. So, what is my molarity? My mass, my grams. My molar mass. No. It's not the molar mass of water. The water is the solvent. It's the molar mass of the solute. What? Say it again. 69.8. Is that right? How many decimal places does silver have? 3? Okay, I thought it only had 2. All right, under my, so I did whatever silver was plus what nitrogen is plus oxygen times 3. And my liters is my question mark. So now this sets up as 2.00. And this is where these start getting to hard into solving, okay? 78.5 divided by 169.873 divided by x. How would I solve this out? I mean, yes, but the easiest way to solve this in the calculator is just divide straight down. And this, it doesn't matter what order you divide in. 78.5 divided by 169 divided by 2. So liters would equal grams divided by molar mass divided by molarity. Okay, that's where people struggle with molarity. Typically, is just the math solving of it out. So the answer is going to be what, around 0. What? 0.231 liters. That sounds about right. That sounds correct. All right, let me work one more example out. I don't want you to get caught in something that you don't know. You got to find the molar mass this time. All right, so there's our question. 47.5 grams of unknown substance is, I should say, is dissolved in 250 milliliters of water. If the concentration is 2.25 molar, what is the molar mass? So as you're writing this down, you need to be deciding if it's gram, the first one or the second one. Which one is it? Second one, because I'm giving grams again. So big M, grams equals, molar mass equals, and liters equal. So what is my molarity? 2.25. What's my mass? What's my grams? 47.5. My molar mass is what I'm looking for. And what about my liters? 0.25. So to plug this in my equation, I have 2.25 equals 47.5 over X over 0.25. How would I solve this out? You would divide, how you would do this one is you would divide this one straight down also. So this would be equal to, so if you're looking for the molar mass, so the molar mass is equal to the grams divided by the liters divided by the molarity. So 47.5 divided by 0.25 divided by 2.25. You get what? No. You're close. Just 84. Okay? Just 84 because you only have two significant figures, don't you? So 84 grams per mole. Now you can check this out, make sure this is right. If you plug in 84 right here for X, if you do 47.5 divided by 84 divided by 0.25, you get 2.26, so it's basically the same, okay? Where this gets difficult is the solving these out, okay? Refer back to this. If you want to write the equations down to how, for which thing you're going for, that might be helpful also. Make sure you turn in your work with this homework. If you have any questions, let me know.